Hello everyone, in the previous video we looked at the relational schema design and normalization. Now that we have learned how to normalize a schema in theory, let's bring it to life with actual SQL code, where we will walk through table creation, normalization via structure, and how to retrieve related data cleanly using join. Originally, data might be stored in a single white table with multiple orders per client in one row. This breaks the principles of one first normalized form. In the previous videos, I showed how unnormalized table looks, but here you can just use your imagination. Let's say we have client, category, order, date, and it's not a normal table, and it has some problems like repeating groups, data redundancy, and no separation of entities. And I want to show you how we can normalize these tables using SQL. First, let's create a table, which will be called client, table client. I will plus parentheses. We will have a client ID, which will be an integer, and it will be also our primary key. We will have a value called name, which will be a varchar, just another way to say string. And I think 50 characters should be long enough for a normal name. And we will have a category. And again, it will be a category. It will be a string, which means varchar, and it should be enough to give it 20 characters as an example. And now let's create another table. This time it will be the client order. So let's better. In this table, we will have an order ID, which will be our integer, and primary key. We will have another variable called order date, which will be a date type. And we will have a client ID, which will be integer. And our client ID will be also our foreign key, which we can give the client ID in it, and it will be referencing from the client ID. So here we created two tables called client and client order. I made a mistake. Nope. And it will be presenting clean one-to-many relationship. Every order links back to the client via foreign key. In another example, we can insert and retrieve data. For this case, let's say we want to insert into the client values of one, name, primary key one, name is big company, and category will be sale. Now let's insert into the client order. And the primary key for the order number can be 101. The date can be 2025, 6th of 27, the order date, the date, and we will have the client ID, which is 1. I forgot to save, I guess that's fine. I just created a new schema, so let's say use new schema typo, and I say Ctrl Enter. When we check the output, we can see, yes, we are able to use the new schema. Now let's create our table in that schema. Yes, we create successfully. Now let's create our client order table, which also happened. Now let's insert into our client. And now let's insert our client order. Now when we say select order ID, order, date, and client's name with client category, and if we get this from the client order and join this with client on client or but client ID, which is also client's client ID, we should be able to see our client's order ID, order date, name, and category. Basically, we insert a client and related order, then we use join to combine both tables in a query. Proving we still get all the information, just more cleanly. Here, another example of city and country separation in third normal form. Let's say we have a client table with city and country introduces a transitive dependency, which will connect the city and country. Again, I am using the schema I just created. I am going to insert the new table, city. I will have a city name, which will alter the table. And I will add a client, altering table client, adding a foreign key, city name, which will referencing the city's city name. As you can see, it executed correct successfully. And in third normal form, we are separating attributes like country that depend on city, not directly on the primary key. This ensures we remove transitive dependencies. Let's simulate an example task. The original table here has multiple products for sale and embedded employee and store info. First step is first normal form. We'll be removing the repeating groups. So if you create a table called sales details, and we can give it a store ID, which will be an integer. Say, let's do the employee ID, which again will be an integer. Let's give it a sales year, another integer. Let's give it a product ID. This can be a string. I will call it varchar and 10 characters. Example. And we can have quantity as integer. In this case, we will have multiple primary key. The unique ones, as you can guess, store ID, employee ID, sales year, and the product ID. primary. This will be our first normal form. See, yes, it is working fine. It executed successfully. The second normal form, this will be about separating store info. Which will be create table, and I will call it store because this is about store info. And for the store info, we will have two variables: store ID, which will be an integer, and will be also the primary key, and we will have store location, and it will be var char 100. Well, as an example, we will save our store table now. In the third normal form, we will be separating and below the info. Again, I will create a table, which I will call it employee, and we will have an employee ID, which will be integer, and also our primary key. And we will have the employee name, which can be a string, which means varchar, and let's give it 50 characters. Enough. Let's check the table. Yes, successfully. And we will have a final table for store employee product and sales detail. And here I will say create table product and this one will have the product ID. This is a one char, which is 10, and it will be its primary key. And this also executes successfully. So from this log table, we created 4 separate normalized tables: sales details, made us. We have the sales details, store, employee, and product. This removes redundancy and helps avoid update and deletion anomalies. Each foreign key connects back to its origin table. These are common theoretical questions. Knowing how to answer them quickly helps a lot in theoretical written parts. They can, let's say together, which normal form removes partial dependencies? It is second normal form. Which one removes transitive dependencies? It is third normal form. Why do we normalize? To reduce redundancy and avoid anomalies. And if you have true and false questions, if a table is in true second normal form, it is also in the first normal form, which is true. And second normal form does not guarantee third normal form. Now we have seen how relational design translates into SQL. Just some simple examples. In the next episode, I want to go deeper into querying, like SQL, getting deeper into SQL, and including like aggregate functions and subqueries. And yeah, we just talked about creating tables using normalized design, using foreign keys for relationships, writing plain inside and joins, and simulating normalization tasks. Thank you for watching and see you in the next one.